Welcome back to the channel. Today we'll be taking a look at this function y is equals to the integral of e raised to power 3x sine x with respect to dx. Now if I'm to integrate this, obviously we'll be using integration by parts. Remember our formula for integration by parts says the integral of u dv is equals to uv minus the integral of v du. So we're to select our u and our dv. Now for this example, I'll be selecting my u to be equals to e raised to power 3x, so that my du will be the same thing as 3e raised to power 3x. I've just used function of a function. And my dv, I'll be selecting it to be equals to sine x, so that my v on integrating sine x is the same thing as minus cos x. Now we can begin to substitute in this equation. Remember our y, which is the integral of e raised to power 3x sine x, is the same thing as uv, that's e raised to power 3x into minus cos x minus the integral of v now. V is the same thing as minus cos x, this minus cos x into du. Du is 3e raised to power 3x dx. Now let's expand this. On expansion, this becomes minus e raised to power 3x cos x plus, minus times minus here becomes plus cos x times 3. That's the 3, the integral of e raised to power 3x cos x with respect to dx. If you look at this, well, we once again have another integration by parts. So this time around, we'll be saying u again is equals to e raised to power 3x, so that the u is the same thing as 3e raised to power 3x, and my dv is the same thing as cos x, and this time around my v on integrating cos x will be the same thing as sine x. When you integrate cos x, you get cos sine x. And when you differentiate sine x, remember you get cos x. But when you integrate sine x, you get minus cos x. Now, so that I can substitute this back into the equation, my equation becomes, I have minus e raised to power 3x cos x plus 3 into, now my u now is e raised to power 3x again, and my v is sine x, and I'm integrating v, which is sine x, v, which is sine x, and my du, obviously my du is the same thing as 3e raised to power 3x, so that this becomes minus e raised to power 3x cos x plus 3e raised to power 3x sine x minus 3 times, I have 3 as a constant in here, times 3, that's 9, and the integral of e raised to power x sine x. Now, if you look at this expression carefully, you see e raised to power x sine x is the same thing as our y here, e raised to power x sine x. The whole of this expression is equals to y, so that I can easily substitute y in this position. So that I'll be saying that my minus e raised to power 3x cos x plus 3e raised to power 3x sine x minus 9y is equals to y. Now, so that this expression, I can easily say that my minus e raised to power 3x cos x plus 3e raised to power 3x sine x is equals to y plus 9y. So that minus e raised to power 3x cos x plus 3e raised to power 3x sine x is equals to 10y. So I can divide both sides by 10 and say that my y now will be equals to minus or 1 over 10 into, okay, I have e raised to power 3x common with both of them. So I'll rather say that I'll have e raised to power 3x over 10 into minus cos x plus 3 sine x is equals to y. Let's rearrange for beautification's sake. This saying that y now is equals to e raised to power 3x over 10 into 3 sine x minus cos x now plus c, our constant. Please don't forget your constant when integrating. Is equals to y. Now with that, we have performed integration by parts on this expression. So with this, I hope you further understand how to treat integration by parts with its uniqueness. Thank you for staying with us and see you in our next class.